Hello, my name is Anna Tobias. This video discusses the visual setup and collected data for our sports engineering project. My group members are Cleo Alberts, Kaylee Pasquarello, Matthew Stavko, and Christine Bay. This is the Tennis Tutor ProLite Plus machine. The capacity is 110 balls, the ejection speed ranges from 10 to 60 miles per hour, and it weighs approximately 30 pounds. It serves as a very sturdy base for the experiment. For our experiment, we set the ball ejection speed to level 5, or around 30 miles per hour. Based off of our calculations, the ball was going about 12 meters per second, or 26.8 miles per hour. As the camera scrolls over the top of the machine, you'll notice that we have 4 balls ready to go. We wanted to get the best possible data, so we tested more than the required modifications to see which worked best. We found that the ball wrapped in rubber bands often got caught in the machine, as you'll see now, and would not launch properly. Therefore, we decided to do a duct tape modification and a hole modification, which we will go more into detail later. The part of the machine that actually launches the ball, that is being shown now, was parallel to the ground at a height of 10 inches. This machine allowed us to have a better confidence that each launch was consistent. Each launch was at the same speed, height, and angle. To measure how far the ball landed from the machine, we did a couple of practice runs to get a general idea of where the ball would land. Then, once we found the general area, we ran a measuring tape along the ground to get an accurate number as shown. Now, proceeding to our first modification, we duct tape a single strip of duct tape around the center of the ball. We did a total of 5 trials. The average distance was 25.2 feet with an average velocity of 13.92 meters per second. Using this information, we were able to calculate a Reynolds number and got an average of 58,241.05. Our next modification were 2 15mm holes drilled into the ball. We drilled the holes into the top and bottom of the ball so that they represented symmetry and we could model such in ANSYS. We did a total of 5 trials. The average distance was 19.38 feet, so less than the duct tape modification, and had an average velocity of 40.248 meters per second. Using this information, we were able to calculate a Reynolds number and got an average of 51,392.42. The last experiment was to leave the ball unmodified and send it through the tennis launcher unchanged. We did a total of 5 trials. The average distance was 20.8 feet, so still less than the duct tape modification, but larger than the hole modification, with an average velocity of 41.263 meters per second. Using this information, we were able to calculate a Reynolds number and got an average of 52,688.37. Thank you, and I hope this video was very informative.